The National Electrical Code, or NEC, addresses the situation of using a 30-amp plug on a 20-amp device. According to the NEC, specifically section 410.56e, it is not permissible to attach a 30-amp plug on a 20-amp device. This section of the NEC states that receptacles shall not be installed on circuits rated over 20 amps unless specifically approved for the application. This rule applies to both 120-volt and 240-volt circuits. The primary reason for this regulation is to prevent overloading of the circuit and to mitigate potential fire hazards. A 30-amp plug is engineered to manage a maximum current of 30 amps, while a 20-amp device is designed to handle a maximum current of 20 amps. If a 20-amp device is connected to a 30-amp circuit, the device could potentially overheat, which could lead to a fire. Considering a situation where someone intends to operate both a bandsaw and a dust collector on a single 220-volt circuit, the bandsaw has a requirement of 10 amps, and the dust collector needs 12 amps. This means that the total current draw on the circuit would be 22 amps. If a 20-amp circuit breaker and 20-amp receptacles are installed for this application, it would not meet the requirements of the equipment. It is essential to recognize that a 20-amp receptacle cannot be installed on a 30-amp circuit. This installation would violate the NEC rule that explicitly states that receptacles should not be installed on circuits rated over 20 amps unless they have specific approval for such use. This is because the circuit breaker is there to protect the wire from melting and causing a fire, and also the equipment plugged into it. Because the circuit can handle up to 30 amps, you could potentially plug in enough equipment into the 20-amp receptacle to damage the receptacle and anything attached to the receptacle. With all of this in mind, it is important to never install a receptacle on a circuit that is over the ampacity rating of the said receptacle. If a receptacle is rated for 15 amps, it can only be installed on a 15-amp breaker or less. Also, a 20-amp receptacle must be installed on a 20-amp breaker or less. In order to determine the correct size breaker and receptacle, one must add up the total amperage draw of the equipment that will be plugged into the receptacle. This includes any tools or other equipment that is used at the same time. For example, if there are lights that are on the same circuit, they must be calculated as well. One must also consider if there are any other receptacles in the same circuit. If there are, that must be taken into consideration as well. It is always best to be safe and install a circuit breaker and receptacle that is larger than what is needed. This will ensure that the circuit is not overloaded and that there is no potential for a fire. When doing electrical work, it is important to follow all safety precautions. This includes turning off the power to the circuit before working on it, using the proper tools, and wearing safety glasses. If you are not comfortable doing electrical work, it is best to hire a qualified electrician. To correctly determine the appropriate breaker size for the load in question, several factors must be considered, including the continuous or non-continuous nature of the load, the ambient temperature, the type of conductors used, and any applicable directing factors. Firstly, the NEC defines a continuous load as one where the maximum current is expected to continue for 3 hours or more. For continuous loads, the overcurrent protection device, such as a circuit breaker, must be rated at not less than 125% of the continuous load. This requirement is in place to prevent nuisance tripping of the breaker due to the heat generated by a sustained high current. Non-continuous loads, on the other hand, do not require this 125% upsize. Secondly, the ambient temperature in which the conductors are installed plays a crucial role. Higher ambient temperatures increase the resistance of conductors, which can reduce their ampacity. The NEC provides ampacity correction factors for various temperature ranges. These factors are applied to the conductor's ampacity to determine its allowable current carrying capacity at the specific ambient temperature. Thirdly, the type of conductors used, such as copper or aluminum, and their insulation rating, such as THHN, THW, or XHHW, significantly affect their ampacity. Copper conductors generally have a higher ampacity than aluminum conductors for the same size. The insulation rating determines the maximum operating temperature of the conductor. The NEC provides ampacity tables, such as Table 310.15b16, that list the allowable ampacities for various conductor types and sizes based on their insulation temperature rating and installation conditions. Fourthly, directing factors must be applied when multiple current-carrying conductors are bundled together in a conduit or cable. The heat generated by each conductor can raise the overall temperature within the conduit, reducing the ampacity of each conductor. The NEC provides directing factors in Table 310.15b3 that specify the percentage reduction in ampacity based on the number of current-carrying conductors in the raceway or cable. In the specific scenario of a bandsaw requiring 10 amps and a dust collector requiring 12 amps, the total load is 22 amps. If both the bandsaw and dust collector are expected to operate continuously for 3 hours or more, the load is considered continuous, and the circuit breaker must be rated at 125% of the continuous load. In this case, 22 amps multiplied by 1.25 equals 27.5 amps. Therefore, a 30 amp circuit breaker would be required. If the load is non-continuous, 25 amp breaker would be acceptable, but 30 amps is a common size and the next size up. Assuming that the conductors are copper, have a THHN insulation rating, are installed in a conduit with no more than 3 current-carrying conductors, and the ambient temperature is within the typical range of 30 degrees Celsius, the ampacity of the conductors must be at least 30 amps. According to NEC Table 310.15b16, a 10 American wire gauge or copper conductor with THHN insulation has an ampacity of 30 amps at 30 degrees Celsius. Therefore, 10 AWG copper conductors would be suitable for this application. The size of the equipment grounding conductor, or EG, must also be determined based on the size of the overcurrent protection device. According to NEC Table 250.122, for a 30 amp overcurrent protection device, a 10 AWG copper EGC is required. Now let's address the receptacles. According to NEC Section 210.21b3, a single receptacle installed on a 30 amp branch circuit must have an ampacity of not less than 30 amps. Therefore, a 30 amp receptacle is required. Additionally, NEC Section 430.53 permits multiple motor-driven appliances to be connected to a single branch circuit if certain conditions are met. These conditions include that each motor must have overload protection, the branch circuit overcurrent protection device must not exceed the value specified in Table 430.52, and the sum of the full load currents of all the motors must not exceed 80% of the branch circuit rating. In this case, the bandsaw and dust collector are both motor-driven appliances. Assuming that each motor has overload protection and that the sum of the full load currents of the two motors does not exceed 80% of the 30 amp branch circuit rating, which is 24 amps, multiple receptacles can be installed on the 30 amp branch circuit. However, each receptacle must be rated not less than the ampacity of the equipment connected to it. In summary, to determine the correct breaker size for the bandsaw and dust collector, it is necessary to consider the continuous or non-continuous nature of the load, the ambient temperature, the type of conductors used, and any applicable directing factors. For a continuous load, a 30 amp breaker would be required, while for a non-continuous load, a 25 amp breaker would be acceptable. 10 AWG copper conductors with THHN insulation would be suitable for this application. A 10 AWG copper EGC is also required. A 30 amp receptacle is necessary for a 30 amp branch circuit. Multiple motor-driven appliances can be connected to a single branch circuit if certain conditions are met.